Welcome to the Deep Dive. Today we're looking at something pretty fascinating, how Oman is using autonomous drones, essentially these smart flying robots, to keep an eye on its vital oil and gas environment.
It's a huge undertaking.
Exactly. We're talking vast areas, critical infrastructure, and think about the usual way manual checks, people out there. It's slow, sometimes dangerous.
Very risky.
So this is about leveraging, AI, cutting-edge tech, for real-time protection.
Yeah, moving beyond the old ways.
Our information today comes from some really interesting research out of Dhofar University, funded by MoHERI Oman and led by Dr. Qamar Ul Islam.
A solid academic basis for this.
Right. So our mission really is to dig into how these drones work, how they're changing the game for surveillance in this industry, and what it means for environmental safety going forward.
Well, the starting point has to be why this is needed, right? The old methods, manual inspections.
Yeah, tell us about that. What are the big problems there?
Well, first off, the sheer scale. We're talking miles and miles of pipelines, often in really harsh, remote desert terrain.
Incredibly difficult to cover consistently, I imagine.
Exactly. It's slow, it's expensive, and frankly, it can be dangerous for the inspection crews. Hazardous materials, difficult access.
And if something is wrong, like a leak.
That's the big worry. An undetected leak isn't just an economic loss, which can be huge, but it's a major environmental hazard.
And a safety risk, too.
Absolutely. So the traditional way, you might only spot a problem during a scheduled check, which could be weeks or months after it started.
Okay, so the drones come in as a better alternative.
A fundamentally different approach. Instead of periodic checks, you get continuous monitoring. Drones patrolling constantly, autonomously.
Giving you real-time eyes on the ground, or rather in the air.
Precisely.
Yeah.
Spotting potential issues almost as they happen, sending alerts immediately. It improves safety, cuts down response time. It's a paradigm shift.
Okay, so continuous vigilance. But how do these drones actually do it? What makes them smart? What technology are we talking about?
This is where it gets really clever. These aren't your standard off-the-shelf drones. They're kitted out with some serious tech. First, thermal imaging cameras.
For heat signatures.
Exactly. Gas leaks often cause subtle temperature changes, even if the gas itself is invisible. Thermal cameras can pick that up.
Okay, interesting.
Then they have specialized gas sensors on board. These can actually, sniff the air for specific chemical signatures associated with leaks.
So heat and chemical detection, a double check.
And it doesn't stop there. All this data, visual, thermal, chemical, gets fed into AI algorithms running right on the drone or processed quickly.
Right, the artificial intelligence part. What does the AI do?
Its job is anomaly detection. It has to learn what's normal out there, the usual heat variations, the background chemical traces, and then spot deviations.
So it can tell the difference between, say, a hot rock and an actual pipeline issue, or engine exhaust versus a methane leak.
Precisely. It filters out the noise. It's trained to recognize the specific patterns, the subtle signs that indicate a potential problem, like a spill starting or a tiny crack forming.
That's crucial. Otherwise, you'd just get constant false alarms.
You would. And, importantly, these drones navigate autonomously. They can fly complex pre-programmed routes over difficult terrain without needing a human pilot controlling every move.
They just go.
They follow their mission plan, covering vast areas systematically.
Okay, so the drone spots something suspicious using its sensors and AI. What happens next? Does someone get a phone call?
A bit more sophisticated than that.
Yeah.
The data, along with the precise GPS location, is instantly relayed to a central monitoring system.
A command center of sorts.
Sort of, yeah. When the AI flags a confirmed anomaly, it triggers an immediate alert within that system.
And that goes
to the field engineers, the response teams. They get actionable reports, what was detected, exactly where it is, maybe even initial severity assessments.
So they can react fast and know exactly where to focus their attention.
That's the goal. It shifts the whole process from being reactive, finding damage after it's happened, to being proactive, catching things early, minimizing impact.
That really does sound like a potential game changer. But, lab conditions are one thing. Has this system actually been put through its paces in Oman's environment?
Oh, yes, definitely. This isn't just theoretical. Their research included rigorous field testing.
In the actual desert?
In select field locations, yes. Because you're right, the Omani desert is tough. You've got extreme heat, dust storms, sand.
Conditions that could easily wreck sensitive equipment.
They could. So proving the drones and the sensors can operate reliably in those conditions was absolutely critical for the project's success.
And how did they fare? Any hiccups?
Well, the reports indicate they performed very well during these trials. They successfully ran dry runs, identifying simulated leaks under those challenging conditions.
So they prove they can handle the heat, literally, and still do their job accurately.
That seems to be the case. It was a major validation step, showing the system is robust enough for real-world deployment.
You know, it strikes me that developing something like this can't just be tech people working alone. There must be other expertise involved.
Oh, absolutely. That's a really important aspect. This project wasn't developed in a vacuum.
Right.
There was close collaboration. You had the drone technologists working with environmental scientists, with experienced oil and gas engineers.
People who understand the specific risks and operational needs.
Yes, exactly. And also, critically, with government regulators, making sure the system aligns with Oman's environmental safety standards and regulations.
So it's a solution built for the specific context, not just imposed onto it.
Precisely. That kind of collaboration is key to making sure innovative tech is actually practical and effective on the ground.
Thinking bigger picture now, this technology, this approach, does it have legs beyond Oman's oil and gas fields?
Definitely. I mean, the core concept, autonomous drones, advanced sensors, AI analysis, it's highly adaptive.
So where else could you see this being used?
Well, think about other types of pipelines, water pipelines, for instance, across the region, monitoring their integrity, or even power grids looking for faults.
Infrastructure monitoring, basically.
But also consider environmental conservation.
How so?
You could use similar drones for, say, wildlife monitoring over large reserves, tracking populations, detecting poaching activity,
Interesting.
or monitoring deforestation, tracking changes in habitat, even things like early fire detection in vulnerable areas or industrial zones.
So the ability to have persistent autonomous surveillance over large areas opens up a lot of possibilities for environmental stewardship and safety.
It really does. It's a tool with broad potential applications.
And I understand this specific project also fits quite neatly into Oman's national strategy,
Yes, very much so. It aligns directly with Oman Vision 2040.
which emphasizes.
Things like developing smart infrastructure, focusing on environmental sustainability, and embracing advanced technologies like AI and automation.
So this isn't just a standalone project, it's part of a bigger national push towards innovation and sustainability.
Exactly. It's a tangible example of putting those strategic goals into practice, using technology to solve real-world challenges in key sectors.
Okay, so as we wrap up this deep dive, what's the main thing you think we and our listeners should take away from this story out of Oman?
I think the key takeaway is that these autonomous drones, packed with sensors and powered by AI, are rapidly moving from being a futuristic concept to becoming really vital, practical tools
Tools for what, specifically?
for protecting the environment, ensuring safety, and managing critical resources, especially in demanding sectors like oil and gas.
It really highlights how technology, when applied thoughtfully, can make a concrete difference in safeguarding ecosystems and preventing potential disasters.
It does. It's about smart application for tangible benefits.
So thinking about that, here's something for you, the listener, to chew on. We've seen how this works for oil and gas in Oman. Where else do you see this kind of autonomous drone surveillance making a difference in the future?
Yeah, what other industries, what other environmental challenges could be transformed by these sorts of eyes in the sky? And as they become more common, what ethical questions or practical hurdles might we need to navigate? Something to consider.